Hello everyone and welcome back to this next lecture. This is where we had left off in the previous lecture where we had compiled the driver lib project, and now we have both projects which have been compiled. So we are now ready to execute these projects on our microcontroller. So with this, I'm now going to bring the microcontroller into the video. So you will now see the microcontroller in the video, and the connections are exactly the same as we did before. 4 connections per CPU, EPWM1 and 2 and EPWM4 and 5. So with this, I'm going to just zoom into the oscilloscope because that's all we need to see. For now, the connections have been made to EPWM1A and 1B, and soon I will change it so that we can see a phase shift. So with this, let me now enter the debug mode. So the code has been downloaded. We can just select it and run it. So you will see now we are getting these complementary gating signals, and that is because we are measuring the gating signals at S1 and S2, which are expected to be complementary. Now in a phase shift PWM full bridge converter, what is really interesting are the gating signals between the legs, which means now I'm going to move the blue oscilloscope, rather channel 2 or the blue waveform, over to S3. So now we are measuring the yellow waveform stands for the gating signals to S1, and the blue waveform stands for the gating signal to S3. So you can now see that they are identical, and they are identical because the phase angle between the two EPWMs is 0. So now let me go and add that in the watch window. So let me go to the watch window, and I'm just going to add it. I think I remember what it is. Phase angle CPU1. So I'm just going to add it, and it is now 0. So I'm just going to make sure this is in continuous refresh mode. It is. And now I'm going to add a positive value. So if I add a positive value, EPWM1, it leads EPWM2. So let's see if that happens. I'm going to add a value, let's say 0.2. And now if you take a look, you will see now the yellow waveform is leading the blue waveform. So the blue waveform comes after the yellow waveform. So this shows that there is now a phase shift between the two legs. And the result is now if we feed this to an actual full bridge converter, the result will be there will be a pulse here, a non-zero pulse, and another non-zero pulse here. So this is where we are going to see two pulses in the PWM cycle, and this is how you are producing pulses of changing width. So now that we have done with a positive phase angle shift, let us try a negative phase angle shift. So I'm going to say minus 0.3, and now you'll see the exact opposite. So now you'll see that the blue waveform is leading the yellow waveform, and if you take a look here, you'll see that now the lead is 30%, because remember our duty ratio is 50%. So which means that if 20%, you can see approximately this is 20% and this is 30% of a single duty ratio. So now we know that we are now able to phase shift the two waveforms with respect to each other. So now that we've done this, I'm going to delete this, and let's go and connect CPU2. So I'm going to connect the target, and I will load the code. So I'll go to driver lib, CPU2 RAM, I will look for .out file, and I will load it. So it is now loaded. I will run it. So of course we have to change over the oscilloscope probes. So I'm going to change the oscilloscope probes. So first, always I will connect to S1 and S2, and we will confirm that they are complementary, and you can even go ahead and confirm that there is a dead band between them, right? So I will change over the blue waveform to S3 because that's what is interesting. And now let's go and add the phase angle CPU2 variable. So I'm going to say phase angle CPU2, and now this is what we get. So initially it is 0. I'm going to put a value 0.3, and let's take a look at what's happening. And now you will see that the yellow waveform is leading the blue waveform. And if you take a look here, the blue waveform, the difference between this is approximately 30% of the duty ratio. So therefore we are accurately able to achieve the required phase shift. So once again, now let me just put a negative number so that we finish our confirmation. And I will say minus 0.2. And in this case now, the blue waveform is leading the yellow waveform. And once again, you can see approximately the lead is indeed 20%. So with this, we are now done with the phase shift control, phase shift PWM for the full bridge converter. So at this point, I'm going to end the microcontroller video. And we have also come to the end of this lecture, and for that matter, the end of this section, right? So this is a very long section. We examined we examined 3 different PWM strategies: the unipolar strategy, the bipolar strategy, and the phase shift strategy, phase shift PWM strategy. So all these are very commonly used in industry, and if you are able to get all these results, then that is a great achievement. So with this, I'm going to delete this, and I'm also going to close down this particular debug mode. So with this, I will end this lecture, and in the next lecture, I will conclude on this section. If you faced any issues or you didn't get these results, please post in the Q&A forum, and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening, and see you soon. Goodbye for now.